Welcome to Conversations with Frank Fabozzi. I'm Frank Fabozzi. My guest today is Francesco Fabozzi. He's widely recognized for his work on artificial intelligence and data science in finance. He previously served as director of research at Yale School of Management's International Center for Finance. His research and consulting focuses on applying advanced data-driven methods to financial markets and investment decision making. He's a frequent speaker on the use of AI in asset management, risk management, and investment research, addressing audience that span from academia, industry, and professional associations. He's the managing editor of the Journal of Financial Data Science. He is the author of the chapter on natural language processing that's published in the CFA Institute's 2025 monograph, which is called AI in Asset Management Tools, Applications, and Frontiers. He earned his undergraduate degree in economics from Princeton University, a master's degree in quantitative finance, and a doctorate in data science from Stevens Institute of Technology. Okay, in this conversation, we'll focus on AI, how AI is reshaping financial research and investment practice, how academic ideas translate into real-world implementation, and what practitioners should understand about the opportunities and limits of AI in finance. Welcome, Francesco.
Thanks for having me.
Yeah, well, I did get your name right, right? It's Fabozzi. Right?
Yeah,
Okay.
yeah.
All right. Okay. Let me toss out this first question and, speak freely. I won't interrupt you. Much of the discussion around AI and asset management emphasizes automation and scale. Now, you have argued that large language models may be more valuable for discretionary investors or portfolio managers. What do you think the industry misunderstands about where AI's real advantage lies?
Yeah, so I discussed that AI is really has opened up new avenues for discretionary fundamental investors because it opened up a set of tools that were previously inaccessible to these more non-quantitative portfolio managers. And this is really before previously we had language models for quants. We've been trying to make sense of text data for a while, dating back to Lofgren McDonald in the early 2000s, and had pretty simplistic approaches. Then in about 2018, we had more of what are known as encoder only models, which are not generative language models that produce text, but rather they represent text as a whole and turn text into a vector that can be used in statistical modeling. So quantitative investors have been using these approaches for a while, and the advent of generative language models really just allowed us to have more sophisticated models to make sense of the textual data in finance, but still allow us to look at it systematically. In terms of discretionary investors, now that we can have models that can actually talk with us, converse with us, gather information in a one-off sort of manner as opposed to having pre-collected a bunch of textual data. Um, Really, it can automate a lot of the roles that you might have a junior analyst do performing at some of these discretionary fundamental funds.
Well, you suggested that smaller discretionary firms may benefit more from AI than large systematic platforms. What organizational or cultural factors make this possible?
Well, I think one is so from a cost perspective, if you think about hiring a junior analyst, right? A large fund or institutional shop is going to have the money to hire as many analysts as they want, where they're performing roles that are just more carefully monitored than having a large language model do this. So one aspect is that you can now have basically a junior analyst be a large language model or an agentic system. Um, but then from a organizational and cultural perspective, you have to be willing to embrace AI technologies and be willing to roll with the punches and figure out what works and what doesn't work. So, it's easier to steer a small boat than it is to steer a cruise ship, so it's hard to sort of implement these AI technologies, especially at the pace that we're moving at. Um, you know, there's every week there's something novel or groundbreaking being produced in AI, and if you're a smaller firm, then you can really decide how cutting edge you want to be. Whereas there's a lot of bureaucracy when you deal with these larger hedge funds.
Well, starting with your doctoral dissertation, much of your work is focused on large uh, language model based sentiment and return prediction. Now, some people may be confused here, but can you explain the difference between sentiment and direct return prediction using textual data?
Yeah, yeah. So sentiment is a largely solved problem in the computer science space. And that's really what a lot of people think about when they think about using news and using that for return prediction. So you get a bunch of news and it's pretty easy to determine whether or not news is positive, negative, or neutral. Previously, we had to get labeled training data sets from financial professionals to look at a piece of text and actually determine if this was a uh, positive, neutral, or negative sentiment when taken in a financial context. Um, but the now with with language models, you can focus on different aspects of sentiment, right? Sentiment doesn't necessarily mean right something that might be generally good, right? Might not be generally considered positive sentiment might not actually result in a return in positive or negative returns. So one thing you could think of is the idea of a news article that says, you know, Apple was up, 10% in morning trading, right? Like that is positive sentiment, but that might not actually mean that you want to buy the stock because there might be some sort of reversal afterwards. So what language models aren't necessarily pre-trained with is they're pre-trained with sentiment because they understand human language, but what they might not understand is how that translates to returns. And there's something called fine tuning with large language models that you can actually train a model to look at a piece of a news article and train it on what that subsequent return was. So that is different. That's where you'll get the differentiation between something that is generally positive sentiment, like Apple being up 10%, that's not telling you there's a trading decision that has to be made after that. Whereas if we look and we take, all of the news in a cross section, and we say that this news article tends to over, the next trading day tends to seem like it has positive sentiment, but actually has some sort of reversal. So your trading decision would actually be the opposite there. You might actually sell that stock instead of buying it if you were operating on traditional sentiment.
Okay, well, you've also discussed how large language models have made workflows for discretionary portfolio managers more efficient, as well as how these models can do the same for quantitative firms. However, how should large language models be used in purely quantitative strategies?
In terms of quantitative strategies, I think there are a few things. Something to touch on in terms of the equivalent of the efficiencies that you gain in discretionary are we're now seeing efficiencies with quantitative portfolio managers. there's and so I'll touch on the sort of more pure quantitative strategy in a second, but in terms of the efficiency gains from that we see in quantitative portfolio managers is that now we're developing these RAG-based systems on proprietary code bases at hedge funds. And this is really key to understand because when we think about we have really good coding agents now. So if you know 90% of the code that is committed on GitHub, which is like the repository for code bases, 90% of that code is AI generated. But when it comes to and so that's because these models are trained on these large code bases, but they're trained on more sort of traditional computer science and data science problems, uh, which means that you for example, there are certain things in finance that you wouldn't want to do when you're training a predictive model in finance that you wouldn't want to do uh, in computer science that you wouldn't want to do in finance. So, like a classic example is how do you split your training validation and out of stable test set in a traditional computer science framework? We might actually just shuffle everything. And if you're trying to predict cats or dogs, that stays pretty much constant. You don't really have to worry about, maybe collecting the same number of samples from each sort of classification category. But with finance, none of these code bases are seeing the light of day. They're all stuck within these proprietary organization. So when you go to think you're training basically all the financial training it has on the code bases is actually looking at maybe a master's student who had a project in school that they put their code base on GitHub. You're not really getting this really well vetted financial financial data science code. So that's really where the efficiencies are coming from for discretionary traders is that you can train it on your own code base. So now if I have the same, I work at a firm and I'm basically writing the same back testing code for my different strategies or across the firm. Well, now we could tell a model to go in and find our back testing code, and then it'll automatically generate it and tailor it towards the analysis that you're looking at. So that's really where you're getting the efficiency gains on the quantitative side. And just want to highlight that, which is sort of different now from the systematic strategies that are coming out of this. And what's really interesting about systematic strategies with this new realm of generative language models is that now you could look at before it was you would take again I talked about that labeled training data set where you'd have a financial professional predict or determine whether a text is positive, neutral, and negative. You're really only looking at like one aspect of sentiment, whereas there's really now that we can converse with these models, we can tease out different aspects of we can create a really just a ton of different variables that focus on different aspects of text. So, for example, we could look at general sentiment as one predictive variable. We could look at, again, like I talked about, the return prediction that we have as another variable. We could also look at, well, let me take all the news in this let me look at all technology news and now actually have a variable that is determining, you know, the sector and the sentiment that's associated with that sector, which could be used as another variable. You could look at, does this affect a company's cash? Do any of these articles affect a company's cash flows? So if you're looking at like value stocks, you might want to they're more sensitive to cash flows. You might want to you can really talk to these models and extract out a ton of different features, which when you're now using it in a quantitative approach, now it's just you have a bunch of predictive variables that you could extract out from it. So it's actually, if you're trying to only use sentiment in or a return prediction in quantitative um, approach, you're really losing all of these different angles of sentiment and all of the different features that can be teased out of the news that are overlooked when you just talk about general sentiment. So I think the way, more generally is you could create a bunch of different variables that could go into a predictive regression, and that could be then an easy way to pair that with more fundamental data, um, and technical analysis data.
Well, you mentioned back testing, so I want to return to that because traditional model evaluation relies heavily on back testing. I don't think enough back testing is presented to board members and how they do it. That's I think an entire industry into it itself. But how should firms assess the usefulness and reliability of large language model based tools that support judgment rather than generate explicit signals?
Yeah, so there's a few different aspects. This is going to be the hardest problem to overcome when it comes to implementing large language models in a quantitative strategy, and this is because there's this issue of, right, time sequencing the language models, right? They inherently remember information, right? So there is this forward-looking bias, even if you eliminate it all in terms of like the methodology that you use, the models still have forward-looking bias embedded in them, and which is why we actually like them because they have this sort of memory. So the issue there is, now some people have looked at, let's look at time sequencing. So if we basically just trained a model from data prior to 2010 and then tested that forward, and kept sort of rolling these models forward, there's a few issues with that too. Is that one, is it's very expensive to train these models, difficult to collect all of this information. It's and you're inherently working on stale technology. So, right, you couldn't expect if a finance firm that wanted to backtest this wanted to create its own chat GPT product. It's not going to be chat GPT that you're using. It's sort of your version of it, which might not be as sophisticated as, OpenAI or some of these other large technology companies. But in order to do that time sequencing such that there's no forward-looking bias, you have to use these weaker models. So you're not testing how the newest ChatGPT does in you're not testing how it does actually um in this you're not testing how it does without forward-looking bias, because you most companies don't have the skill or the time to be able to train a model to be exactly replicating the newest advances in technology. So it's a difficult problem now, and the way that I think about, if we're doing this in a more quantitative approach, is that variable creation that I've referred to, is that we can create models that have less that are smaller models that have maybe not as much memory that we can train in this time sequenced approach. These smaller models we can train, but we need to be able to um so we don't need to rely on the most sophisticated, newest technology. We can create these features from without the newest technology, and I think that that will help us get a better idea of how these actual language models perform. It's not like now these models are getting more sophisticate they're getting more sophisticated, but the gains are really coming from, like, the tools and the whole system engineered around the newest AI technology, and not so much the models becoming more and more sophisticated, which they are, but that is easier to test in a quantitative approach. The other aspect of this is really coming up with evaluation data sets. So you can maybe not look at it in terms of a back test, but you can look at the predictive strength of these models uh, by masking companies, sort of abstracting the text such that the model can't actually understand. So, for example, we you might do something where you replace Apple, a news article associated with Apple. You could replace that with Microsoft and maybe make it a little bit more specific to Microsoft, but then train it on that Apple return associated. So really coming up with these evaluation data sets is going to be really important for companies who are looking to for firms that are looking to back test and it's really going to be creating a lot of synthetic data that's sort of throwing off the model and not allowing it to rely on its memory of financial history.
What do you see as the most important model risk concerns associated with, let's say, generative AI when people apply it to investment decisions?
Yeah, so now we're getting to the now coming back a little bit to the discretionary aspect where we're looking at the systems that are making our decision making more efficient. And the the biggest concerns there are as you make it's these large agentic systems that will use multiple different models that one model might specialize in getting financial, connecting the financial APIs, extracting the information you want. Model might be taking a question and understanding the parameters that you have to feed into these API models. And as there are more models, as newer models come out, people are looking to replace old models with new models, and these systems become can become very fragile because one little aspect of a change in one submodel, that change might propagate through the whole system, and now you're ending up with something completely different than what you had intended. So evaluation data sets, now talking about it in a different way, they call it evals in the large language model space. You will have, for example, after you run something through your pipeline, is it hitting all of these sub models that you expected it to go through? Is it actually teasing out the information that you're expecting it to tease out and pass on to the next model? Is after the final all it goes through all of the models, is it spitting out in the formatting that you want? Is it spitting it out in you know, the type of interpretation that you want at the end? So one little change can propagate through the whole system, and that's really where people need to ensure, especially when a lot of the people who are using these models and systems are not necessarily um the experts. So the engineering team has to make sure that these everything is working in the intermediate layers. But then on top of that, hallucinations, which everyone knows about, but really even experts can be convinced that a model is performing uh the right task. So or coming to an answer in the correct way. So one example I gave was I was looking talking to some financial advisors at a conference, and you know something someone might ask is, what are the top performing fixed income funds? What are the top performing fixed income funds in 2025? So if you don't audit the model, it's going to come up with very plausible text. You're going to say, okay, there's a BlackRock, Vanguard, Fidelity fund that you know are probably potentially top performers, and you'll read it and you'll see all the citations that it's getting from the internet. But there's one red flag there is that this model or the ChatGPT, for example, I gave the example with ChatGPT, is it's not connecting to a price feed API. It's not connecting to a price feed and then going through and calculating the returns and then giving you some ranking. It is going based off of what's on the internet. And so what's on the internet then is a lot of now it's just a publicity thing of, you know, who was discussed the most, which of these funds are discussed the most in the news. And now ChatGPT is going to assume that that is these are the top performing funds. And if you go and you look and you go through and there's actually in this example I had given, there was one link that actually was connected to a price feed and had sort of a running live feed of who were the best performing fixed income funds. And that was completely different from what ChatGPT had produced in its response. And these are the things that you can really be duped by these models. Everyone thinks that it's something that you'll be able to see. If you're a sophisticated user, you'll be able to see sort of if the model's hallucinating or not, or finance, so you could probably determine. But it's really these little things in the way that you might ask a junior analyst, well, how did you come to this answer? And then you realize, oh, okay, well, that's gonna inherently result in something faulty. So that's really where the biggest risks are. We're making decisions based on we're making financial decisions based on a faulty underlying logic of the models.
Well, do you think with the widespread adoption of large language models, that will lead to more homogeneous investment thinking? Like everybody's basically a robot? Or do these tools naturally support differentiation in thought?
This is I think what one of the more interesting questions, and I've thought about this a lot, right? When you think about, you know, if these models are all very similar, right, then they might come to similar conclusions. But I think the tools that will come out um, are going to be such that they facilitate you to create the agentic process, what process to go through, and then you will and then it will be up to you to put your secret sauce in there, right? So you will have situations where you'll have a like you have something where you have your internal documentation, your internal um uh company reports in your agentic system such that that's unique to you. You'll have your investment thesis, your investment philosophy, you'll have your mandates that in your agreements, your investment agreements, and this certain constraints. These models will be able to understand that, and part of the reason I mean, a lot of technology, if you're a technology focused fund, you might have be pretty similar to other technology focused funds, but we do get differentiation in financial markets based off of the needs of the customers, of the needs of your clients, right? And a pension fund is going to have different needs from someone who is running a family office. so so I think inherently that will create differentiation, and then at the same time, I think that these internal reports, investment theses will allow the model to have differentiation. And so I don't think they'll be all homogeneous, and it will be up to the user and what is fed to the model to create that differentiation.
Well, what distinguishes rigorous AI research in asset management from work that is technically impressive but economically weak?
Um, the one of the things that is going to be the next wave of AI in finance is right now there are most models are or most of these companies in fintech are using are using are basically stock selection agents, right? They help you do the research on an individual stock and that individual and you're gonna keep asking about individual stocks when you're okay, my portfolio, I don't like this company anymore, but let me find a replacement that has similar statistical, that has similar attributes or is matching some sort of thesis that I have. So they're really just stock selection agents now or stock selection, their ability, but not that many people have focused on portfolio construction over stock selection. So for example, when I need to have certain, I'm doing value at risk and I'm looking for a stock to replace another stock. I wanted to account for all the statistical relationships in my portfolio. I wanted to understand the correlation with other assets in my portfolio. I wanted to understand how this is going to affect value at risk, conditional value at risk, and and really take into account all of these things, right? And what and even when you're managing larger portfolios in a quantitative way, these models aren't necessarily producing numbers that would then allow for some portfolio optimization uh, algorithm. But you know, you could translate some of this into numerical data that then you have a model that understands. Okay, this is here. Oh, you want a minimum variance portfolio. Um, you want you want this sort of portfolio optimization. You need these statistical attributes of your portfolio. So right now, I think there's that gap in that really you could take a lot of in the current realm of things, you could take a lot of purely computer science people with no sort of investment experience or even like really more sophisticated quantitative finance experience. And you could just tell it, go look at the news, go calculate these basic return metrics, go do the, but it's going to take now this blending of portfolio theory and stock selection and really how do you blend all of these things together. So I think that's where um right now we have technically impressive research agents, stock selection research agents, but no one is really taking into account the portfolio as a whole.
Was it about 8 or 9 years ago? The Journal of Financial Data Science started. We believe it was, one of the first that focused it. There's a lot of data science journals around, but we believe it was the first journal that focused on financial aspects of data science. You were the managing editor from inception, and you've seen lots of manuscripts come in. How has the nature of AI related research submissions changed in recent years?
So originally, it was like I discussed before. These sort of it was really for people who were NLP experts. When we first started the journal, it was a lot of any NLP um, research was coming from people who were pretty much experts in that space, understood like language models as a whole, and then it came to how do you implement this in a strategy and really a lot of these again vector based understanding the news and then either predicting returns directly or predicting sentiment and then seeing how that was done. But now you see people who are maybe not as much experts um in AI, but or sorry, in language models, but now they had certain theses that they sort of wanted to test that you couldn't have someone read every news article and extract. Well, what's the narrative? What is the market narrative that is coming out of this collection of news? You know, it's it can spit out natural text, natural language that can then be interpreted and then put into portfolios. So now you're seeing a lot of different things, like the way that I said that we could have many different variables coming from the same piece of news. Now enumerating all of these different variables, it's now gonna become like the factor zoo, but for text. So you're gonna have the textual factor zoo, right? So, um, did
But
this article
explain,
mention.
not everybody may have read the paper on Camel Hobby. What do
Yeah,
you mean?
yeah. So the vectors, it was really, there was all, you have a, but basically a vector being like a variable that could be used in constructing a portfolio. And starting with the Fama French or Cap M Fama French. And so now everyone is trying to look for, at a certain point, people are always trying to look for a sort of a single variable that can be constructed that can, you know, result in a profitable, risk adjusted return portfolio. And the idea is that now you want also factors that are orthogonal or uncorrelated to other well-established factors. So there's been, hundreds of papers that have tried to discover this in more traditional quantitative finance using sort of fundamental data, traditional financial data. But now I see this going I see this looking at text data as, oh, well, if you prompt the model in this way and you tell it to look for, does this have anything to do with, um, you know, a CEO, or what's the sentiment towards the CEO? What's the sentiment towards the industry? What's the sentiment towards, you can name it. That's really where I think people are now going to say, well, sentiment is sort of the basic factor that we're looking at, but now you can get these other ones that maybe are a bit orthogonal, uncorrelated with what is traditionally thought of as sentiment, and just looking at different um, aspects of the news and teasing out certain things that you know a discretionary investor might have had this in his head, the whole you know had something like this in their head, that the whole while they're making investment decisions. But now we can actually try to translate that to using large language models. So I think that's really where we're going to end up, is what is the best news factor, or what are the collection of news based textual data factors that we could use in finance to predict returns, or to price the cost section.
Well, looking ahead, where do you see AI will most meaningfully change how investment decisions are made rather than simply, how information is processed?
Yeah. So I think that there. So right now we're in the stage where we're gaining efficiencies through processing information, but I think that, again, sort of touching on this aspect of all these different I think it's going to be the blending of the quantamental approach, but in a more rigorous in a more rigorous way, that now we can figure out how do we, instead of just asking for um sentiment or different aspects of that you can tease out of text, or your own proprietary information. I think we're going to figure out how to sort of price, how we're going to extract quantitative data from these unstructured text data, and then how do you then formulate that in a portfolio that might not just be a traditional optimization, might not just be a traditional portfolio optimization, but is some optimization that is taking into account, you know, various aspects of how the variables were formulated, things to that the model should be aware of. This isn't going to be done in a textual manner, right? But I think that there's going to be a new way of there's going to be more research in portfolio optimization, given that there is um, that we're not going directly from a purely quantitative fundamental data approach or traditional data approach, but sort of blending the two. Then, I mean, obviously, I think that there's going to be more autonomous decision making, but that's gonna take some time, and it's a risky endeavor, but it's gonna be really the model is gonna be looking for new opportunities, new, sort of investments or changes to your portfolio, and sort of surfacing this to the portfolio manager, as opposed to the portfolio manager directing the model to find some information. So you might, as a portfolio manager now, if you were implementing AI, you might have sort of your investment thesis and how you evaluate stocks, and that's in a document that the model can then look at and call. But in the future, it will understand that this is your investment philosophy, here's your portfolio, but hey, you might actually be overlooking this aspect of your investment philosophy. It's going to surface information that we didn't tell it to. Look for your weaknesses. And that's really where I think it will be really helpful in eliminating a lot of blind spots that people might have.
You know, when I've retired from the board of the BlackRock funds, but we used to have every quarter, or we would vary it, but we would bring in portfolio managers and we would ask them their views on certain things, why they constructed the portfolio in certain ways, and they would give you a reasonable response based on some fundamental principle or investment beliefs. How do you deal now if you were brought in to a company to train the board of directors of a fund, and specifically focusing on AI? What types of what how would you train them? Tell them how to be prepared to deal with portfolio managers. Have you ever given that any thought?
Yeah, I mean, how to deal with I mean, I think that there are definitely certain way, right? Because it typically in that case, you're not gonna have the board members necessarily being the ones that are using that AI, and but they could be what they should be aware of in looking at portfolio managers. So for example, like what are the biggest downfalls that a portfolio manager could have that that is again, well, you have like the hallucinations, and you have sort of making sure if I were to go and I were to look at, okay, who are the portfolio managers who are relying on AI right now? Like, what are the safeguards that they have in place? How are they evaluating their models, capabilities, and the capabilities of their agentic system as a whole? Right. What are the differences between I mean, I could see just all new reports being generated based on looking at where are the same way, like if you see a new model coming out, like a new generative language model, if you look, you'll always see like a bar graph as to where the model did on certain benchmark data sets. Then everyone says, oh, this is now the best model. Well, you should you should be able to tell me as a as someone who's evaluating you as a portfolio manager, what are the evaluations that you're using? How are you coming up with these? Because this is a huge thing, and it takes being creative. It's there's not You're not going to read a book and understand how you should evaluate your model on uh well, it can give you ideas, but it's very you have to be very specific in how you do this. You might have to have another language model that's evaluating your agentic. Yeah, yeah, exactly. It's not going to be how well did it match the text that we expect? Well, no. Well, if it's better, then we want it to generate something new entirely. But and if you gauge sort of the output of a previous system with a new system, how many times? What's the percentage of times that it is better than your previous system? What is it matching the style that we want? Okay, this could be a binary thing. Is it matching the style, right? Is it sort of teasing out? You could have a rubric that you feed a model, like the same way you would grade a paper, right? When you're in school, is did it follow these aspects? Give a point system. So anytime we're looking at this, it should be evaluation specific. How did you implement any new submodels or any of the newest models? What is the delta between that model on these evaluation sets and the old model? Um, Looking for sort of having a or having a sort of really tricky data set or a really tricky problem that the model might currently not be able to solve, like something you expect the model to fail at, right? You have these sets of questions and evaluations based on that. And now, okay, well, does this new sort of model coming out, does that actually help you? Um, is it now cracking these problems that we didn't see before? So, I as someone on the board of what one of these companies, that's really what you have to be looking at is you want to see a whole evaluation report being generated and understanding what's your reasoning behind these evals, why are you performing it this way, do you see a better way to do?
Yeah. One of the things you mentioned safeguards. I think, a lot of people are talking about guardrails, having those in place, as well as another thing I believe people are going to be facing is, uh, you know, how if they have an idea and it can't be explained to others, if there's ever an issue where someone performed extremely well, you know that the SEC can come in and inquire as to where you got that information. I think that's going to be a concern with people. But the job of the job of members of board is going to be very tough. It's difficult being a board member if your field is not finance in general. So you have to worry about finance. Now having to deal also with this, as well as there's going to be a lot of ethics issues that I think are going to be brought up. I don't know if you've ever tackled them, but we agreed we wouldn't talk about your new position yet. I mean, that's why I didn't mention it at the beginning. But in that new position, you'll be and you have hired people. What do you look for in people and helping you in working in the AI area?
Well, I look for people with right now, I look for people who are who have domain expertise, right? So I'm looking for not necessarily the best AI modelers right now or the best coders, really. That's something that isn't as long as someone has some projects that they've done, then, I'm not really concerned with coding given the way that coding has trended. I mean, obviously you want smart people, but someone with domain knowledge where you understand what the end user is gonna want. You understand what they want, and then you have the ability to so if we talk about guardrails again, right? I could say to I could have a model that I say to go do some uh something a little bit like go do a factor, attribution or portfolio attribution analysis, right? There's some decisions to be made, look back windows at, and these are things that the model would then have to make decisions on its own if I told it to do that. But what we could do now, and what the advantage of a lot of these large quantitative institutions that have access to code bases is that, or their own proprietary code bases, is that, well, we don't want the models making that decision. I want someone who has been doing it, sort of a portfolio attribution in this case, and knows, well, we prefer to go to this look back window versus this look back window, and we use sort of this approach over this approach, um, and have some reasoning to it. I don't want the model to make those decisions, because the model hasn't done this in the real world. I want to know that the person that I hired is going to just create the code that I can then call on, as opposed to the model having this code. So I'm really looking for domain knowledge. Um, domain knowledge is where we can eliminate some of these variables that the model is going to have um, in the background to have to choose amongst.
Some people may be wondering what your background is. Did you start out, were you as a child, were you like one of these computer geeks where where you did a lot of programming? Because there's a lot of brilliant kids around. At 10 years old, they're really well versed in computers and actually building systems and all that. You, on the other hand, really never got involved with coding until you graduated from Princeton, right? And all that. What do you recommend to uh, someone who's interested in starting in this field, who didn't start off as, let's say, an engineer, but in your case, you took the finance courses at Princeton, and then the quantitative finance program at Stevens. But I still remember you when you after you graduated during that summer, you were learning how to program. Okay. When you asked me if you should take a course in Princeton in programming, I discouraged it only because they have that system there where if you have like two lines of code that match someone all the way back to 1995, they'll throw you out of school for a year. So I told you it's better not to take that. But I remember during that summer, um, you know, yeah, I don't know if I was impressed, but or I found it odd that you were learning how to write something so that if you showed a picture of a dog, whether or not it would be, I guess that's the basic thing they do when they teach that. What recommendations do you have for people? We know a lot of people who are their children are starting in data science, but let's suppose someone wants to start after they graduate and they've already have a domain specialty. What do you suggest? What advice?
Well, so right now it's a completely different landscape from when I was learning. I couldn't imagine learning now, right? Because it's, I mean, I guess the same way you have ChatGPT, right? That could help you coach you through a course or like a tough problem that you're thinking about. But thing that I would always say is, well, people also now are, before people would try to say, "Oh, I want to learn Python," and they would try to learn the syntax of the language, and then you're going through hours of exercise, and you're like, when the heck am I ever going to use this stuff? Like when would I even use like an if statement or like a for loop? When does this make sense to use, or um things like this, where you're just kind of like learning to learn. I think of it as like if you're learning a language and you're doing like a Duolingo where you're not actually like trying to practice speaking, right? It's all project based, right? So and that accomplishes two objectives. And one is to understand um sort of how coding works, like how you automate systems, and as problems come up, you start to solve it, and then as you do that enough, you actually end up learning coding and all of these things. Um, and then second, now you have a portfolio that you can show to people and say, "Hey, look, this is what I did." I'd much rather have someone say, "Oh yeah, here are like two cool projects that I did," than someone who's like, yeah, I got my undergrad in computer science and blah blah blah. Like, I think that is projects are really how you learn, because especially nowadays with the language models is you the most popular coding language right now is English. So so that is the most popular language right now. So, but the thing is that you have to understand the same way that if you're trying to communicate an idea that you don't understand, or you don't understand the inner workings of an idea, well, it's going to take you a lot longer to communicate that idea, or solve the problem, if you don't have this underlying understanding of it more generally. So, same way, if I'm coding something and I'm trying to figure out why something's not working. I'm trying to debug the program. Well, for me, it's like I've been doing this long enough that I know, okay, well, here's sort of exactly what are my candidate issues. Here's like I know how to reference this to my coding agent that's going to write the code for me, as a first pass. Um, but if you're not doing projects and you're just kind of trying to learn by syntax, that's like definitely the worst way to go about it nowadays. But just doing projects is really going to help you understand, um even taking a project, downloading it, from GitHub, downloading it locally, and talking with the model about the code base. Well, what part of the code, why are they using this language on this part of the code base? Why are you using like TypeScript on this part of the code base and then Python on this other part? Like, things like these are these questions that you take for granted once you know a lot about it. But you can learn a lot by taking a project that you like, or doing a project that you like, and trying to solve it, or taking someone who already has a solution to it and understanding their code base. So, it's a lot different now, and I think you just want to get hands-on experience, as opposed to concerning yourself with syntax, or sort of low level conceptual ideas.
Well, let's wrap this up, and I appreciate your time. I've done about 50 of these conversations with Frank Fabozzi with different closing statements, but this one is going to be simple. Your mother told me to tell you she loves you very much and she's very proud of you. And I'm proud of you also. And we won't keep this on longer because you're turning red already. I already see. So
Yep.
that's it. Thank you for the interview.
Yep. All right. Thank you.